So today we're going to talk about interpolation. I don't even know if that's how you say it, but that's how I say it. So all that is trying to find a point along a line or a curve or a graph in between two actual points of data. So for instance, if we want to get something between 25 and 30 gallons. Oh my God, David, you suck at this. Um, Turn your phone to silent, dickhead. Stop messaging me. Right, where was I? So, all we need to do to find a point on this line between 25 and 30 gallons is to work out how quickly it's going up for every gallon it's going across. Uh, and all that is, let's bring up the calculator. You might remember from high school maths, rise over run. So the rise from 20 gallons to 25 gallons is 136 and 170 pounds. So that's 170 minus 136, which is 34 pounds. So that means as you've increased 5 gallons, you've increased the weight by 34 pounds. Now, to divide that by the run, which is 25 minus 20, 5 gallons, you get 6.8. Now we knew that already because it says right here, weight of fuel increases linearly with the amount of fuel, so it's just 6.8 pounds per gallon. That's, I guess, the specific weight um, of fuel. But say we wanted to get 26 gallons, the weight for 26 gallons, we would just do the weight for 20, 25, which is 170, and we would plus 6.8 gallons. We get 176.8. If we wanted to find it for 28, that's 3 more than 25, so 3 times 6.8 is 20.4 pounds. You add that to 25, the weight for 25 gallons, which is 170, and you get 190.4. Now again, because this is linear and we know it's 6.8 pounds per gallon, all we could have done is just 28 times 6.8 and we get the same answer. But we can apply the same principle to all the other. Oh man, that was off screen, wasn't it? You idiot. So we then go down to center of gravity. First of all, I'd just like to say that they've messed up my graph with this table. They should have used the center of gravity of the smallest amount of fuel, which would have been about 130 or maybe a little bit less, uh, which is why the graph looks so shit. And which means if you try and interpolate a value between 0 and 5 gallons, you're going to be pretty inaccurate. But having said that, it's going to be pretty light and you're not going to fly very far anyway. It's not going to make much of a difference. But yeah, the same principle applies. Say we want to get a value between, what is this? 25 gallons and 30 gallons. We would do the same thing. We would see how much the center of gravity changes between 25 and 30. Now from here you can see it's 0.7 inches. Now if we divide 0.7 inches by 5 gallons, which is the run. Remember, rise over run, rise is 0.7 inches, run is 5 gallons. That's the wrong graph. It means you get 1.14 inches per gallon. So if we want to work out for 26 gallons, we just plus 0.14 to 137.4. And we get 137.54. And we can do 5 gallons. Not that we need it because we have the value 430 anyway, but we can just use it to check our answers. So it would be 5 gallons times 0.14, which is 0.7, and then we would add that to 137.4, gives us 138.1, which is correct. That's probably a stupid example, but let's try 28 gallons, which would be 3 gallons more than 25 times 0.14 gives us 0.42 gallons. So that means we want to add 0.42 gallons, we're going to go up just a little bit, 0.42 inches, sorry, from the center of gravity at 25 gallons. So 0.42 plus 137.4 means the center of gravity of 28 gallons is 137.82 inches. Now, once you have your interpolated weight and your interpolated uh, center of gravity, you can just multiply the two by each other. What did we get for 28? We got 6.8 plus 173 is 18, 20.4. It should be 190.4. So 137.82 times 190.4 gives us 26,240, which is somewhere between 23,000 and 28,000. So that's great. And that's going to be pretty accurate. You can also um, just interpolate the moment altogether instead of working out the moment from the interpolated weight and center of gravity. Better turn my work computer on because I'm about to start. Um, I don't know why. There may be a good reason why AFT say to calculate it, but the answer is going to be within like 0.01% anyway if you just do it this way. And so maybe you just want to get the moment. Maybe you don't actually care about the center of gravity and weight, but maybe not. So if we wanted to straight interpolate the moment at 28 gallons, we do the same thing. So we take the rise at 30 to see what's the rate of increase at this point, which is 28,172, and we would minus the moment at 25, which is 23,358. So we've got 4,814 is the rise in moment. Now we divide that by 5, and we get 962.8 is the rise in moment per gallon of fuel added. Now, say if we use the same example, 28 gallons, we would times this by 3, and we would add it to 23,358 inch pounds, which gives us 26,246.2, which I think would have been close, pretty close. It's off by 6 inch pounds, which is, yeah, less than 0.01% or thereabouts. So voila, there is my first take shitty video.